This video covers false prediction number 3. Evolution occurs by mutations adding up in the genome causing some sort of change to occur. And you've probably heard that mutations are random. But evolutionists don't mean that mutations are completely random. They can be non-random. For example, if the environment shifts and maybe the mutation rate changes. Maybe some part of the genome has more mutations than another part of the genome, and so forth. So you can have non-random trends in mutations. But mutations must be random in one particular dimension, and that is with respect to need. Mutations cannot be caused by a need. Let's say you have an environmental shift, you need thicker fur. That cannot trigger a mutation to occur that gives you thicker fur. Mutations must be random with respect to need. That is to say, they cannot be adaptive. So, false prediction number 3, mutations are not adaptive. Let's have a look. I'm going to show you some examples of evolutionists making this false prediction, and you'll see how important it is to evolutionary thought. But first, we need some context. So I'm going to cut to an earlier video that I made entitled DNA Methylation, the Falsity of Evolution, to get this much needed context. So here goes. Well, to understand this, we need to step back and look at teleology, a fundamental concept in origins and outside of origins. Now, more than 2,000 years ago, the great Greek philosopher Aristotle, perhaps the greatest philosopher ever, was comfortable with teleology. Teleology is this idea that things in the natural world have a purpose, have a goal, an objective, or what philosophers refer to as a final cause. He would be comfortable with this statement that teeth are for chewing food. When you see this infinitive form of the verb, it indicates a goal or a purpose. For chewing. Teeth are for chewing. This is their purpose. Aristotle was comfortable with this concept of teleology. Well, it's a bit of common sense, right? Well, not according to the Epicureans. They were against this concept of teleology. They said that teeth are not for chewing, but rather teeth formed by chance, and because they could chew, they persisted. You see the flipping around of the logic here. Now, why would they say that? It seems kind of odd, right? Well, the idea behind this is that God would not and must not have designed the particulars, the details of the world. God must not have designed or created the details of the world. And why? Because of the problems in the world, the inefficiencies, the ugliness, the lack of aesthetics, the evil. Lucretius, another Epicurean, in his epic poem De Rerum Natura, explained this, and here's a quote, that in no wise the nature of all things was for us fashioned by a power divine. So great the faults it stands encumbered with. This is the key, the faults. This is what's driving, this is the underlying reasoning, the faults, the problems, the inefficiencies. If you say that God designed the teeth in order to chew things, you must also say that God is responsible for the toothaches and for all the other details of the world that we don't like. If we need to get God away from the details of the world, then we must say that the world arose by itself. Now Lucretius concludes here, quote, "For nothing has been engendered in our body in order that we might be able to use it. It is the fact of its being engendered that creates its use." So the logic, again, is flipped around here. This is anti-teleology. It is opposed to teleology. Now fast forward a few thousand years to 1859, Darwin publishes his book on evolution, The Origin of Species, which is full of this anti-teleological reasoning. Darwin finds problem after problem in the biological world and concludes that the species must have arisen by chance because of all these problems. Darwin was an anti-teleologist. Evolutionist John Rice has written, "There is no way to understand the rise of evolutionary theory in the Enlightenment except in the context of an anti-teleology derived directly from Lucretius." Rice draws that line and makes that link correctly. Now, Darwin supporter Thomas Huxley very succinctly summarized all this. I'm going to show you this quote here, but before I read Huxley, let's just again read the Lucretius conclusion. "For nothing has been engendered in our body in order that we might be able to use it, it is the fact of its being engendered that creates its use. Now let's read Huxley, 1871. For the teleologist, an organism exists because it was made for the conditions in which it was found. For the Darwinian, an organism exists because out of the many of its kind, it is the only one which has been able to persist in the conditions in which it is found. Far from imagining that cats exist in order to catch mice well, Darwinism supposes that cats exist because they catch mice well, mousing being not the end, but the condition of their existence. I really like the way Huxley so succinctly summarized this teleology versus anti-teleology. And that's what we have here, teleology versus anti-teleology, or design versus chance, or the inheritance of acquired characters versus chance and natural selection, or Lamarck versus Darwin. And here's a paper that explains that this is what Lamarck is remembered for. For most biologists and the general public, a Lamarckian is someone who believes in, quote, the inheritance of acquired characters. Now let's look at August Weismann. Weismann came a generation or so after Darwin, a late 19th century German thinker who very much agreed with Darwin and disagreed with Lamarck, and he nicely clarified the distinction between the two. There is Weismann, and if you look at the bottom of this chart, Weismann made this distinction, this model between the germ cells and the somatic cells. So in a multicellular organism, the germ cells, that would be the sperm and the egg, get together, form the zygote. The zygote divides and forms the rest of the growing body. Those are the somatic cells. And you see the arrow goes one way from the germ cells to the somatic cells. In other words, the information flows only one way from the sperm and the egg. That information flows into the somatic cells, the rest of the body. It doesn't go in the other direction. And that was very important. That's called the Weismann barrier. It does not, there's no reverse arrow there. And if you look at the quote here, this rules out the inheritance of acquired characteristics proposed by Lamarck. You see, the inheritance of acquired characteristics, like the weightlifter, you lift weights, that's your somatic cells, your muscle cells, acquiring more muscle mass. That information has to make its way back to the germ cells in order for Lamarck, in order for the inheritance of acquired characteristics to be true. You have to have that reverse arrow. Weismann declared that impossible, not going to happen. That is the Weismann barrier. Very important. Weismann nicely made that distinction and laid out that logic that was fundamental to evolutionary theory. Now, why is that so important? If you look at this 1904 quote from Weismann, and especially the last sentence here, Weismann explains that if we have this backward arrow, if we allow for the inheritance of acquired characteristics, then that's tantamount to calling upon a supernatural intrusive force on the part of the Creator. So Weismann, it was important for Weismann and the evolutionists in general that God not be creating the details of the world. Remember? Straight out of the Lucretius and the Epicureans. God must not be creating the details, not intending for, designing, or creating the details of the world. God is standing off. He's off a ways. He's not in the details of the world. And Weismann makes this clear. If we allow for Lamarckianism, if we allow for the inheritance of acquired characteristics, if we allow for this backwards arrow here, if the Weismann barrier doesn't prevail, then we're opening up the door to this supernatural intrusive force on the part of the Creator, and that is not going to work. You see how important religion is in evolutionary thought. It runs all through evolutionary thought. Okay, so with that context of Epicureanism and the Weismann barrier, this prediction should make sense. Mutations are not adaptive. If DNA mutations in the genome are adaptive, that would mean that information about environmental threats, about the needs of the somatic cells are getting back to the DNA, breaking the Weismann barrier. So this is a fundamental prediction of 20th century evolutionary theory. Mutations are not adaptive. So with that context, let's go and look at some examples. Sir Ronald Fisher was a leading mathematician in the 20th century. He also was a leading evolutionist, doing much of the theoretical work underpinning 20th century evolution. And his work was very much based on the assumption, the premise, that mutations must be random with respect to the organism's need. Sir Julian Huxley also promoted this idea. Now, Julian Huxley was the grandson of Thomas Huxley, otherwise known as Darwin's bulldog, for aggressively promoting Darwin's new theory of evolution, a contemporary of Darwin, Charles Darwin. And there in the upper right, you have a photo of the young Julian Huxley sitting on the lap of his grandfather. And then in the lower right, Huxley is in his home under the portrait of his grandfather on the wall there. So definitely a family lineage here. So Huxley wrote, "Mutation is a random affair and takes place in all directions. Their effects are not related to the needs of the organisms." Very important here. Next, a French biologist, Jacques Monod, a Nobel laureate, wrote, "Chance alone is at the source of every innovation, of all creation in the biosphere. Pure chance, absolutely free but blind, at the very root of the stupendous edifice of evolution." Continuing, "This central concept of modern biology is no longer one among other possible or even conceivable hypotheses. It is today the sole conceivable hypothesis, the only one that squares with observed and tested fact, and nothing warrants the supposition or the hope that on this score our position is likely ever to be revised." Wow, what a statement by Jacques Monod. Very strong kind of truth claim with metaphysical underpinnings throughout about how important it is that the universe is driven by pure chance. This is his book, Chance and Necessity, where that quote comes from. And there on the cover, you see the little blurb there, a philosophy for a universe without causality. And then a few pages in, there's a quote from Democritus, "Everything existing in the universe is the fruit of chance and of necessity." So obviously the motivation for the title there. This book, Chance and Necessity by Monod, was actually derived from a series of lectures that Monod gave at Pomona College in 1969. And that's described in the preface, quote, "before a very young and eager audience." So it's kind of tells you a little bit about the life in academia. This is what you get in science too often, is this strong doctrine and dogma rather than empirically derived information. And we're going to see here that Monod's high claims, and this again, the lectures come from 1969. The book came out in 1971. It would not be long before Monod's high claims were proven to be false. Now here's a 1990s paper out of Richard Lenski's lab, kind of reckoning with the emerging evidence of adaptive mutations and kind of trying to describe, how could this work under evolutionary theory? But my point here is that the paper very much recognizes that this is a hill to die on, and these ultimately, what appear to be adaptive mutations must actually owe their existence to random mutations. So the quote here, "The fundamental tenet of neo-Darwinian theory that mutations are random with respect to their selective utility." So again, they're not letting up. This is the evolutionary premise, very strong claim. Fundamental tenet. Here's a later paper that echoes this same sentiment here. "Mutation is assumed to create heritable variation that is random and undirected." Very important. So, yes, this would all be proven to be false. This is a prediction that did not hold up very well. First, I'll give just some examples here. In bacteria, quote, Recent evidence strongly suggests that both adaptive mutation and hypermutation are induced responses to stress. So in other words, you have a stressful challenge, an environmental challenge to a population of bacteria, and adaptive mutations are observed. That was a 2005 paper. Here's another paper. Taken together with our other studies, the data presented here suggest that directed mutational events that overcome metabolic stress are affected both by transcription and supercoiling. So they've got a couple of mechanisms there. Here's another paper. This mini-review suggests that sensitive, directed feedback mechanisms initiated by different kinds of stress might facilitate and accelerate the adaptation of organisms to new environments. Now, it's not just bacteria. In yeast, this has also been observed. Here's a paper that discovered adaptive mutations that provide buoyancy in yeast to reckon with oxygen-poor liquid environments. And they write, quote, "Thus, mutations in cis-regulatory sequences and variations in gene-associated tandem repeats, two of the main mechanisms that facilitate rapid morphological evolution, are the remarkable genetic events that account for the adaptation of flora yeasts to oxygen-limited liquid environments." Now, here's another paper that experimented with yeast, and they write, "The adaptation was due to a response of many individual cells to the change in environment and not due to selection." Continuing, "This study therefore details a process that is different from the fundamental common view of adaptation." In other words, evolutionary theory. Okay, in flax, so it's not just unicellular organisms such as bacteria and yeast. These sorts of adaptive mutations have also been observed in plants, in this case flax plants. This study found repeatable mutations in flax plants in response to varying fertilizer levels. Quote, "The identical genetic insertion was observed in 5 independent experiments." Very powerful finding when you find the same genetic change, the same mutation occurring in independent experiments. "These events cannot simply be a result of random stochastic probabilities." Here's another paper that also is looking at flax, and they note in this paper, the role of the environment in generating adaptive mutations is still a contentious subject. So, yes, very contentious, and that's why the context was so important to understand how important this prediction is for evolutionists. Continuing, the results reported here show that in flax, a reproducible insertion, that's a mutation event, a reproducible insertion event can occur in direct response to the growth environment, and this event may be directly selectable. So when they say growth environment, they're talking about environmental stresses, various environmental stresses like fertilizer levels, things like that. And that event, when they say selectable, they mean that it go through the germline to the next generation, and then it can be if it's helpful, then it will continue to propagate through the population. The insertion arises during the development of the plant and appears in the leaves. Continuing, the results reported here demonstrate that the environment can act both as an inducer of variation within a limited subset of the genome and then as the subsequent selective agent among the variants generated to genetically alter the majority or all of a population, as has been previously proposed. So these are a few examples from the literature of how this prediction has failed. As one commentator recently put it, the view that mutations are random with respect to need, quote, has been breaking down from the moment it was proposed. So yes, actually these sorts of evidences do go back a ways. Okay, so we've seen the prediction and its falsification. What about the outcome? Because it's the outcome that's so important on these false predictions. Do we have a resolution? Do we have new knowledge gained that resolves the false prediction? Or do we simply have just so stories and ad hoc explanations? Well, one outcome is denial. Yes, evolutionists have simply been in denial about this, and I have personal experience with this myself, and I wrote a blog about it here. You can see the blog. I put the link down below. Let me just read this a little bit from the blog. In the spring of 2006, I gave a talk on the campus of Cornell University, and afterwards was joined by then Cornell professors Richard Harrison and Kern Reeve for a sort of panel discussion or debate about biological evidences and origins. I presented a dozen or so interesting and important evidences that I felt needed to be recognized in any discussion of origins. The evidences falsified key predictions of evolution and so needed to be acknowledged and reckoned with, one way or another. One of the items on my list was, yes, what we're talking about here, the so-called directed adaptation mechanisms, which broadly construed can include everything from non-random directed mutations to epigenetic inheritance. But I was in for a big surprise when Harrison and Reeve gave their response. Now, skipping down, I was shocked when Harrison and Reeve flatly denied the whole story. Rick waved it off as nothing more than some overblown and essentially discredited work done by Barry Hall and John Cairns back in the 1970s and 80s. But there was a body of work that had gone far beyond the work of Hall and Cairns. Incredulously, I responded that entire books had been written on the subject. Rick was quick to respond that, quote, entire books are written about all kinds of discredited things. Sigh, true enough. It was me versus two professors on their home turf with a sympathetic audience, and there was no way I was going to disabuse them of what they were convinced of. So it was a surprising experience for me, and it wasn't the only one. That sort of denial I've run into again and again discussing and debating with evolutionists about this evidence. So that's one outcome of this false prediction, is just simply denial. Now it's interesting to contrast that with, of all people, yes, Thomas Huxley, who wrote, "Sit down before fact as a little child. Be prepared to give up every conceived notion. Follow humbly wherever and whatever abysses nature leads, or you will learn nothing." In other words, follow the data, follow the evidence. Well, that sounded good at the time maybe, but unfortunately too often that's not what happens in evolutionary thought. And this is one example of that. Another outcome of this false prediction is doubling down, where evolutionists look at this and say, well, okay, random mutations create the non-random mutations, the adaptive mutations. So first they said there was no such thing as adaptive mutations, but then when it became undeniable, the response was, well, they owe their existence to random mutations. Evolutionists have responded with the explanation that random mutations did it. In other words, mutations must be random, not adaptive, but if there are adaptive mutations, they owe their existence to random mutations. So evolution does it all here. It creates the mechanisms that create these adaptive mutations. For example, back to this 1990s paper out of Richard Lenski's group, it makes this exact argument that the adaptive mutations you observe in bacteria are merely products of random mutation ultimately. So let's chart this out from an evolutionary perspective. You begin with random mutations and natural selection. That's the classic evolutionary model. They then somehow cause the evolution of mechanisms that will cause adaptive mutations to occur when the organism is presented with an environmental challenge. Okay, so random mutations and natural selection are setting you up for success by causing the evolution of mechanisms that will cause the adaptive mutations, or help to cause the adaptive mutations to occur when you have an environmental challenge sometime. And there's all kinds of different environmental challenges that can occur. Then, sometime in the future, you have an environmental challenge that comes along, and voila, those adaptive mutations meet the challenge. So that's the kind of narrative that the evolutionists are proposing here. There are at least 3 problems with this. First, random mutations must create mechanisms that cause adaptive mutations. Now, the paper explores several examples of this, and in each example there is some DNA sequence in the genome that is key, that's part of this mechanism. So you have these segments of DNA that are necessary for this adaptive mutation to occur. So let's look at some of these genetic sequences in DNA that are doing this. So in one case, it's the thymine and adenine nucleotides repeated over and over again, about, say, 10 times. So TA, 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 TA. Another example is what's known as poly-A, just a bunch of adenines in a row. In this case, 17 or 18 in a row, adenines. Another case is CAAT repeated over and over again, in this case about 16 times. So you have these signatures, these sequence signatures in the genome that enable these adaptive mutations to occur. And so the idea is these would have been the product of random mutations. So random mutations must insert these specific sequences in the correct genome location. And that's an astronomically unlikely event. You have not a very specific location in the genome where that has to happen. Not a whole lot of variability there. And then you have a specific sequence that has to happen. For example, what are the chances of random mutations inserting CAAT 16 times in the correct location? Now, what we're going to see in a minute, there's more to the story than this. We're just warming up. But right away, we can see a probability problem here. The second problem is, even if that number 1 could happen somehow, even if random mutations were to somehow create these mechanisms, it would not be selected for. They would not be selected for. Because these specific sequences in the correct genome location provide a benefit against a future environmental challenge, only when that challenge exists. So if somehow random mutations were to luck out and create this correct sequence in the correct place, it would be of no benefit until that particular environmental challenge arose. And so it wouldn't be selected for. It would not persist. Mutations would degrade it immediately. Andreas Wagner describes this sort of problem. When you have a structure arise that will help not immediately but in the future, he calls it second order selection or indirect form of selection. So it's going to be beneficial at some time, but it's not right now. So he calls it a dispositional trait. You are setting up a good thing. It's beneficial to the population at some point, but not now. So the selection can only work if it somehow knows about the bigger picture. Of course, that has all kinds of teleological implications there. It's a big problem. There is no such thing as second order selection without some sort of a more storytelling. One of those stories, one way to tell that story, is to say, well, perhaps the mutations that need to occur to set up that sequence, for example, the CAAT repeated over and over again, perhaps those also have an immediate benefit. So yes, you're setting up a future capability. You're setting up the mechanism to respond to some future environment. It also helps with something else right now. So it's got an immediate fitness improvement. It is fitness enhancing by itself, and it's also creating an adaptive mutation mechanism for the future. So you see now it's becoming even more unlikely. It's got to be the right sequence in the right place, and it has to have both the immediate improvement as well as this long-term fitness enhancing feature against some future environmental stress. We already saw that the random mutations must find the correct genome location and be the correct type of mutation. Now we add that these mutations must be immediately fitness enhancing. This is astronomically unlikely. So the theory of evolution is taking on a lot of serendipity and a lot of complexity. Now, the third problem with this idea is that it's self-referential. In other words, what do I mean here? The idea that random mutations are ultimately causing these adaptive mutations to occur means that evolution is constructing more evolutionary mechanisms. Evolution is creating evolution to occur, self-referential. That's another serendipity problem. Evolution creates evolution. Back to Andreas Wagner here, he says, he puts it, Darwinian evolution can help create the conditions under which Darwinian evolution becomes possible. That's a self-referential process. This requires an earlier biological world without such adaptation capabilities. Then evolution creates the adaptation capabilities, thus enhancing evolution. It's just a lot more complexity, a lot more serendipity. And you have to have this earlier biological world which doesn't have these adaptation capabilities. That may not even be possible. Okay, so evolution enables evolution. We have a prediction, we have a falsification, we have a response that wasn't pretty. So we have a lot of failed theory virtues as a consequence. We don't have a smoking gun, we don't have new discovery of new knowledge. I will say this, it has spurred on a lot of ideas. And so I would say fruitfulness is not a problem in this case. So let's look at our theory virtues that you're using to evaluate these false predictions. Evidential accuracy, causal adequacy, internal consistency, internal coherence, universal coherence, simplicity, durability, and fruitfulness. So like I said, I think fruitfulness is okay on this one because you do see a lot of papers. Just to be fair, a lot of interesting ideas. I don't think anything is going to pan out or work, but at least there is a lot more work coming out of it. What about the other 7? So let's go through those. Evidential accuracy. Well, we have a prediction that is flatly false, a very important prediction that fell on its face. So obviously we're lacking evidential accuracy. Causal adequacy? No, there really is no plausible cause for this at this point. It's storytelling and ad hoc narratives. Internal consistency? No, I don't think so. Now you have evolutionary theory appealing to both random mutations and adaptive mutations and somehow trying to make them mesh. Once they realized they could not deny the adaptive mutations any longer, yes, you do have internal contradictions. Internal coherence. The theory's components are coordinated into an intuitively plausible whole. No, we don't have that. Lacks ad hoc hypotheses. No, we have, that is what we're seeing is ad hoc hypotheses tacked on to solve isolated problems. That's exactly what we're seeing here. Universal coherence. The theory sits well with other warranted beliefs. No, this is astronomically unlikely for this to occur. Simplicity, no, this is where it really falls down. You lose all simplicity. The theory is violating Occam's razor, losing parsimony. It's becoming incredibly more complicated. It's definitely not, it's definitely losing the virtue of simplicity. Durability, no, the theory fails on yet another prediction. I think fruitfulness is the only virtue here where it gets a pass. So again, fails on evidential accuracy, causal adequacy, internal consistency, internal coherence, universal coherence, simplicity, and durability. Religion drives science, and it matters.